Welcome back to Simply Holistic. Dr. Tony here. We have been talking about hormones, the steroid hormones, the non-steroid hormones, the gamut of the whole thing, those that we know of at this point. So I'm going to use a uh, different study. This will go into some of the fundamentals of the types of hormones. We've got peptide hormones and steroid hormones and tyrosine derivatives. Peptide hormones, which, by the way, the list on the previous video that we went over, that talked about both peptide hormones and steroid hormones. So the steroid hormones, we've got 12 of them in the body are steroid hormones, 10 of which are to do with your sexual functioning. Beyond that, we have 60 plus that are actually peptide hormones. Maybe I should hit steroid first this time. Let's do that. Okay, so the different types of hormones. Since previously we hit steroid hormones first, let me hit that. The steroid hormones are synthesized from or made from cholesterol, and then therefore lipophilic, freely diffuse across cell membranes, and have a structure of 3 contiguous cyclohexyl rings joined to one cyclopentyl ring. We've covered this a few times, they are made from cholesterol. So when the pharmaceutical doctor says, hey, let's lower your cholesterol, let's suppress it, well, that lowering of that cholesterol directly impacts your steroid hormones. And that doesn't just mean your testosterone, your estrogen's in there, your progesterone's in there. Ladies, your ovarian function, your ovarian health is in these hormones. The cortisol is also in there. So when they say, let's give you a pharmaceutical drug to suppress the cholesterol, that also impacts your cortisol. That is what wakes you up in the morning. It's known as the fight or flight hormone, but that is what actually wakes you up in the morning. It spikes in the morning to get you to wake up and get out of bed. So if they're lowering your cholesterol because it's bad, your cholesterol is high and you got to lower it, that's going to, by default, impact how willingly you get out of bed in the morning. Okay, so steroid hormones are made from cholesterol. They freely diffuse across cell membranes, which are made out of fats and proteins, the cell membranes, the outside of the cell. These cholesterol derivatives differ in their side groups and covalent bonds, which permits binding to different intracellular receptors. The composition of the steroid hormones made from cholesterol, but the way that they are laid out, the arms and legs of where it all goes, the actual building blocks of that hormone, differ in their side groups and bonds, which permits them to bind to different intracellular receptors. So the receptors are antennas. Each of your cells has a receptor, has an antenna. It's looking for a specific hormone or messenger to attach to it. These cholesterol-created hormones, the steroid hormones, are looking for specific receptors. These receptors are outside of your cells. Outside of your cells, on the outer casing of the cell membrane, receptors sticking up, and the hormone's looking for that so it can come by and go and attach on the steroid receptor. Steroid synthesis creation begins when the endocrine cell is stimulated by a peptide hormone. For example, ACTH, leading to cleavage of stored cytoplasmic cholesterol esters and shuttling of newly freed cholesterol to the mitochondria. The mitochondria is where you're going to get your energy from. It's the power plant of the cell. Metabolism and mitochondria. Think about that. They go together. The cholesterol side chain is then cleaved by cholesterol dismutase, forming pregnenolone. This is both the first committed step and the rate-limiting step in steroid synthesis creation. Tissue-specific enzymes determine further transform. Tissue-specific enzymes determine further transform. We're missing something there. Determine further transform pregnenolone to steroid end products. Okay, we'll skip that. Using the adrenal cortex as an example, other cells form aldosterone via aldosterone synthase and route the pregnenolone towards cortisol formation via another chemical structure. Cells further route precursor towards sex steroid formation via 1720 lyase. Okay. So through this, the sex steroid hormones are created from the cholesterol that you have in your body and that you take in. Created from the cholesterol. The cholesterol is not just about clogging your arteries and giving you heart issues. It's not about that. It's about balancing your sex steroid, your steroid hormones, not just the sex, but the cortisol too. Your steroid hormones, keeping them balanced. That's what your cholesterol is actually all about. Now, come up here to the peptide hormones. The peptide hormones are, okay, the steroid hormones are cholesterol, made from cholesterol. They are made from fat. They can go through the fat membranes, the cell membranes. Fat activates them. The peptide hormones are water-soluble, different from the steroid hormones. Water-soluble molecules composed of amino acids linked by imide bonds. They exist as single polypeptide chains or as multimeric proteins ranging in size from 3 to 200 amino acids. Okay, so when we are taking in foods, bodybuilders, when you take in protein shakes, or actually even weight loss, when you're going for weight loss, whatever your reason is when you're taking in protein shakes, normally the shakes are marketed as having a full range of amino acids. You're looking at, depending on the source, you're looking at 20 or 21 or 22 amino acids as the full range, full spectrum of amino acids. Out of those 20, 21, or 22, you have different combinations of those. The amino acids are the building blocks of the protein. So out of those 20, 21, or 22, that's the protein building blocks. Those amino acids, they have to get together in different combinations to form proteins. 20 to 22 amino acids joining together end to end in different combinations to form different proteins. So now we have proteins ranging from 3 amino acids to 200 amino acids. Think of all the combinations that are involved in there. They commonly derive from a single gene, multimeric proteins being an exception. The peptide hormones act on cell surface receptors, again, the cell surface, the outside of the cell. Even the peptide hormones are looking for receptors, antennas, on the outside of the cell. The steroid hormones are looking for receptors, antennas, on the outside of the cell. The peptide hormones are looking for the same thing, but they're different receptors, different antennas on the outside of the cells. The peptide hormones act on cell surface receptors and therefore must be capable of exocytosis after translation. First, a ribosome translates a signal sequence that docks it to a signal reception particle on the rough endoplasmic reticulum. the surface. Translation continues within the rough endoplasmic reticulum, and the growing peptide is cleaved from its signal sequence, forming a large pre-pro hormone, which is cleaved to a prohormone packaged in a vesicle and sent to the Golgi apparatus. We're talking about muscle tissue here. The Golgi is a key to that. So the peptide hormones, amino acids, they're used for muscle tissue anyway. Well, all kinds of tissue, but muscle tissue is what we're most familiar with. So the amino acids link together to form a protein, to form various proteins. These proteins, the cells have different antennas, different receptors looking for those proteins. A protein attaches to that cell receptor, the specific one for that protein. The amino acid, the protein that is linked to that cell, diffuses through the cell membrane. It comes apart, and pieces of it go through that cell membrane. So the protein breaks back down into amino acids, and those amino acids go inside the cell. What does this have to do with hormones? We're getting there. So the growing peptide is cleaved from, and it breaks apart, which goes, the amino acids that come off that protein are then joined to, within the cell, joined to other amino acids that are already there and waiting. It's coming from one form, one shape, coming through the cell wall into another form, joining up with this other group, forming another form, another shape. This is a hormone. Inside the cell, this is a hormone. So this hormone is growing. Cleaved from its original source, cleaved to a prohormone packaged in a vesicle, sent to the Golgi apparatus. Golgi apparatus is part of the muscle fiber. We won't worry about that yet. In the Golgi, peptides are cleaved into their final form and packaged into secretory vesicles that enter the cytoplasm. These vesicles undergo another transformation upon cellular stimulus. The cell gets stimulated, which means an electrical signal has gone through to stimulate it. Classic examples of this processing are pre-pro-PTH, pro-PTH, and PTH, as well as pre-pro-insulin, pro-insulin, and insulin. The secretory vesicles also often contain cleavage products in addition to the hormone, as seen with insulin and C-peptide. Those are hormones that we test for in this office, which are co-secreted in concentrations. In addition to cleavages, other modifications occur in the RER and Golgi, namely linked amino acid side chains, which means the amino acid is growing bigger, the protein is growing bigger. Let me continue this rest of this excerpt here, and we can go into this a little deeper. These hormones range broadly in size and structure. The hormones range broadly in size and structure because the amino acids breaking off from the proteins are joining to the hormone. As the amino acids join to the hormone, it grows. The size, the structure, different directions, it grows. The hormones range broadly in size and structure, but several peptide families are of note. Glycoproteins are a group of heavily glycosylated alpha-beta heterodimers. The alpha subunit, 92 amino acids long, and shared by all peptides of this class. 92, there's one length of a hormone. This family includes this family. We're talking about peptide hormones being made from amino acids, which is the proteins. The proteins that you eat get broken down into amino acids. Those amino acids then get made into hormones. We will have to come back to this. Pardon the interruption. Okay. See if we can finish this here up. All right, these hormones, yes, range right. This family includes thyroid stimulating hormone. This is coming from the amino acids that have been broken down. The protein you're ingesting is broken down into amino acids, which then comes through the cell walls, which then gets put into other formations to form different hormones. The protein you ingest gets broken down and put into other shapes. This family includes thyroid stimulating hormone, TSH, and the gonadotropins, which are follicle stimulating hormone, luteinizing hormone, human chorionic gonadotropin, HCG. This family, the thyroid stimulating hormone, the TSH, we check for that. We test for that here in this office. In fact, that's on my initial standard testing. I'm looking at that level. The initial standard female hormonal panel contains the FSH and the LH. I'm looking at all these levels when we start treatment. I'm looking at the levels for your TSH, FSH, LH, because it tells me a whole lot about what's going on inside your body. The POMC family consists of hormones derived from a single protein product that is cleaved at various lysine residues into multiple active peptides. Again, it's broken down from the protein you're taking in and is put into other forms, including ACTH, which is something I'm also watching for, because if I suspect a tumor, I'm going to be testing your ACTH. The posterior pituitary produces two peptide hormones that differ only in two amino acids. Two different hormones that differ only in two amino acids between the two. Oxytocin and ADH. ADH is another one that, depending on what I suspect with your health, I will be testing. Both are nonopeptides with a disulfide bridge, which get packaged with carrier proteins called neurophysins. The insulin or insulin-like growth factor, IGF, family of hormones are peptides with 3 bonds. Insulin is a 51. Alpha subunit is 92 amino acids long. Insulin is 51 amino acids long, consisting of 2 polypeptide chains, while IGF is a single polypeptide comprising of 70 amino acids. Insulin-like growth factor. The insulin itself is 51 amino acids long. The IGF is 70 amino acids long. The growth hormone GH family are large, single polypeptide chains of approximately 200 amino acids long that have 2 internal bonds. This group includes growth hormone, prolactin, and human placental lactogen. We test for, depending on the suspicion. Depending on the suspicion of what's going on with your health, ACTH, let me back up. TSH, FSH, and LH, I'm going to be testing for right off the bat. I'm going to see where they are. Depending on my suspicion with your health conditions, the ACTH, the ADH, the prolactin, and the GH, I will also be testing for, depending on my suspicion of your possible health conditions. So we have a lot of different lengths of amino acid chains here. The thing is, these peptide hormones, they're made from amino acids. So here's a difference. Here's a difference I want you to wrap your head around. The peptide hormones are made from amino acids. The amino acids you're eating, taken in via shakes, if you do it that way, or you're taking it in via food, which everybody does it that way. The amino acids is the protein. This is the protein that you're taking in through your food, the protein from your food. It gets broken down inside your body, taken apart, and then those individual amino acids get put into cells and put into other shapes. It comes into your body in one shape as a protein. It gets taken apart and put into another shape inside your body as a hormone. The protein that you are eating, that you are ingesting, is made into certain hormones. Your thyroid hormone is made from the protein that you're eating. Your 2 of your female hormones are made from the protein that you're eating. Your pituitary hormones are made from the protein that you're eating. These same hormones I check for example, if I have a suspicion of you having a tumor, I will test for some of these hormones. These are protein hormones, peptide hormones made from the protein that you're taking in, the amino acids in the protein. The protein that you're taking in makes these hormones. Thyroid, FSH, LH, things I check for right off the bat when you come in here. If I suspect, for example, a tumor, your ACTH, your ADH, your growth hormone, your prolactin, all these are made from the protein that you eat each and every day. Beyond that, that's 60 plus of your hormones. 60 plus of the hormones doing stuff inside your body that are made from the protein that you are eating every day. Wrap your head around that. The protein that you take in or that you don't take in are being used not only for your muscle tissue. It is used for that also, but not only for your muscle tissue, but also for 60 plus of your hormones that you are being used and created every single day in your body. Your chemical messengers coming from the nerve fibers, the signals sent out from your central nervous system, going through these hormones, and these hormones are producing signals that tell your body what to do. The protein that you're eating every day, 60 plus hormones in your body. Now, the cholesterol, we don't want to suppress your cholesterol. The cholesterol that you're taking in every day, the fat that you're taking in every day, then gets used to make 12 of your cholesterol, 12 of your hormones in your body. The cortisol, to wake you up in the morning, and all the sex steroid hormones to keep the rest of your body balanced. So the protein is used to make 60 plus hormones that you're eating every day. The fat that you're eating every day, so you need to eat fat, you need to have fat on your body, is used to make 12 hormones, 10 of which are to do with your sexual reproductive system. Are you wrapping your head around this? The protein and the fat that you take in every day is vital. The protein needs to have the full range of amino acids because you need them all to make all these different hormones. If you are missing amino acids in your body, there are certain hormones that are going to be suffering. If you are missing amino acids in your daily intake, you have hormones, out of these 60 plus hormones, you have hormones that are going to be suffering. So when you're in this office and we're treating you for hormonal issues, and you're not taking in the right amino acids, you have hormones that are going to be suffering. Therefore, body processes are going to be suffering. Body processes. Your hormonal balance is going to be off. Why? Because you're not taking in the full range of amino acids each day. Or body processes are going to be off because you're not taking in the cholesterol you need to take in each day. The full range of amino acids and the cholesterol that you need to take in each day. It needs to be there. Because otherwise you're coming into this office and we are treating you for hormonal conditions. So many things that you battle each day. So many things that you battle. Your moods, your energy, waking up, going to sleep hungry or not hungry, the tone of your skin, the skin color, the complexion of your skin, the elasticity in your skin, your actual blood flow, the health of your vessels, the health of your heart, yes, the health of your reproductive organs, the health of your kidney, the health of your liver, health of your kidney, the health of your liver, the health of your muscle tissue, the health of your connective tissue, your brain power, the brain fog or lack of brain fog, how clearly you're thinking, how clearly you see, all these different functions within your body. Yes, it's hormonal. Yes, every one of these conditions is hormonal. And because they are hormonal, it's directly impacted by the protein and the fat that you take in each day. The protein and the fat, the cholesterol, everything that we just listed in your body is directly impacted every day by the protein and the cholesterol that you take in each day. So if you're on a pharmaceutical drug that suppresses your cholesterol, review back everything that the cholesterol is used for and think of the damages that that pharmaceutical drug is causing to your body. This is not about clogged arteries. It is so not about clogged arteries. Go back through that list and let it sink in everything that is damaged from the pharmaceutical drug that's suppressing your cholesterol. Think about it. This is so much bigger than clogged arteries. So the protein that you're taking in or should be taking in every day and the cholesterol that you should be taking in every day goes to all the functions that we just covered, all the hormones that we just covered, the hormones that are shown on the panels, on our testing panels, the blood work, the hormonal work that we do in this office every day, the hormonal shortcomings, I'll say it that way, the hormonal shortcomings that you are feeling in your body because you're not taking in the right protein, right amino acid range, and the right cholesterol each day to feed these hormones to build your body processes. With this said, find us at justsimplyholistic.com. Come down into our Simply Holistic office. Get your intake paper done. Let us review your intake paper with you. Let's go through our gamut of testing. Let's see where your hormones are. Let's see where you are deficient. Let's see which, we're not going to dive into that, probably not immediately, which amino acids you're not taking in, which cholesterol you're not taking in, although the cholesterol will be on the test, and I'm going to show you, hey, your cholesterol is at this level. We need to raise this one. And it's almost always the case. We need to raise this particular one through the roof to help body processes that are suffering. We look forward to seeing and serving you soon.